Hello, everyone, and good morning. So I think we're ready to start our next session. For sure, it will be about generative AI. Yeah. So again, good morning. My name is Victor. I am developer advocate from AWS. And before I joined to AWS, I work as DevOps engineer. And I believe you will understand why it's so important during our presentations. And today I'm so excited to be in one stage with Victoria.
Yeah, and my name is Victoria, and I'm also a developer advocate. So we have Victor and Victoria from developer relations team today. But prior to becoming a developer advocate, I actually worked as solutions architect for over 2 years at AWS. And that's why I'm really excited today to talk about how to build solutions architect agent, something that I wish I built for myself in the past and also gave to my customers. And I want to tell you about a typical day of solutions architect. So as a solutions architect, I was responsible for providing the technical guidance on how to build products and services on AWS. And as a generalist SA, I would get on the customer calls, and they would ask me pretty much about anything. It can be about a business problem that they're trying to solve, or maybe something about like a latest announcement that they saw. For example, Victoria, tell me about zero ETL with Amazon Aurora and Redshift. And I will be like, oh, I also saw this announcement. I'm not sure what to tell you. So very often on those calls, I simply didn't have an answer. And it kind of made me feel very inefficient. So what I would try to do on those calls is to understand why they're asking these questions, understand their requirements, what they're really trying to solve. And then I would go and do my research. I would check our internal websites, wikis, documents. I would check any kind of customer stories, how other customers try to solve similar problem using reference diagrams or customer slides. Then I might check with our service teams if it's a technical deep questions or a specialist teams, and then go to console and try to build myself to understand how it works. And then I would take all of this information into, let's say, PowerPoint or some kind of a GitHub repo, and then schedule a call with my customer, and days later, present them my answer. And they would say, oh, this is wonderful, Victoria. But we don't need this anymore. We now have a different question. And then I would need to go and do the cycle again. And as you can imagine, it just made me feel very inefficient. I often felt like I wasn't smart enough. And no matter how hard I tried, how many nights I spent trying to build things, I just couldn't catch up with the pace of innovation. So what we want to talk today is about how you can take your responsibilities, break them into well-defined tasks, and then use AI to automate those tasks so you can be more productive, feel more fulfilled at your job, and deliver business outcomes faster. So now Victor will tell you about AI agent capabilities that will allow to do this.
Yeah, for sure. So before we start to create something, let's look at the main components of generative AI agent. So first of all, what you will need, it will be some LLM model. So in our case, it will be Amazon Bedrock with multiple models, like Anthropic, for example, Claude 3, or Llama, and something else. So what else we need? So you know, LLM has, I would say, drawbacks. So sometimes we need to get a data what's very important and related to real time. So for example, I want to order a ticket from Berlin to Munich. And LLM don't know what exactly currently happened with flights, with train, with bus, and so on. And through the actions, we can make this call to external services and get the real-time data. So in your case, it can be your internal enterprise solutions. So you can get the data from your internal system and figure out what's currently happened with your whole application. On the top of that, you see we have some instructions, prompt engineering. Prompt engineering is how you communicate with LLM. Prompt engineering is very, very important part of agents because it's where you describe what the role of agent will be. As you see, I missed knowledge base. Knowledge base is the heart of your agent. Knowledge base is where you upload your custom data. So you already store a lot of data. For example, how you process a refund of your customer when the customer decided to refund some components and so on. So this is where you upload to knowledge base. So maybe you made some decisions in your architecture to bring Kubernetes, for example, in your architecture. So again, you upload to knowledge base. But what exactly knowledge base? Most commonly, you see its name as retrieval augmented generation. So we have our data, which we have to split in small chunks, make it embedding to our model. And I would say, how I call it in normal way, we translate our data from people language to computer language and store in vector database. So it helps a computer to understand what the context is. And for example, when we will communicate through this agent with our knowledge base, we will enrich the prompt. So it means like, I want to make refund of this order. So knowledge base has a lot of information about refund process. And we enrich our prompt and ask LLM with the whole context to explain more what's exactly happening during the refund, for example, or when I want to make an order of my tickets from Munich to Berlin. Knowledge base can help us really to avoid hallucinations of LLMs, what sometimes can be very, very important. So what we are going to build today together with you. So we are going to create solution architect agents, which we will have 3 main tools. The first one is answer the questions. So I don't know everything in AWS. So through these agents, I will be able to ask any questions related to AWS or maybe my own custom solutions, my own custom architecture. The next one, as solution architect, very often I have to do some prototype. It means like to prepare architecture and infrastructure of this architecture. So I want to generate a code. And you remember I said I am from DevOps world, so we will do it in Terraform. It's my choice. And for sure, we want to make some estimations. We want to say, hey, your prototype will be cost $5,000 or $300. So based on the code, what we will generate in Terraform. So all of these 3 components, it's build our agents. But our main goal of this presentation is not to show you that how you can build solution architect in AWS. The main goal to show you inspirations that what you can do in your own business, in your own custom infrastructure, how you can implement your own custom tools in agents.
Well, now that you know what we're going to build, you might be wondering how hard it is to build. So the first thing that we're going to do, we will build tools that we will then give to our agent, and then the agent will use to execute a particular task. And let's talk about how agent actually works. A lot of the things when we will start showing building abstracted away, so it's kind of like a black box. So what actually happens behind the scenes? So let's say we have a task and we are wondering how it is to build e-commerce website and what's the monthly cost to run it on AWS. So we prepare this task, we ask agent for a task. Then agent puts together a prompt, and the prompt will include a task. It will include any conversation history that you had earlier, and it will also include all the descriptions of the tools that the agent has. And in this way, it can then utilize the chain of thought algorithm and think about, okay, well, which tool I'm going to now start to get this particular task resolved. And it can create a plan with the subtasks, with step-by-step process, and then it will start execute. And the plan with step process can be either retrieving information from a knowledge base, what Victor just described, or it can be executing API and connecting to some other enterprise systems. And once it executes the steps, it will get results back to an agent, and an agent will say, okay, well, do I need now to course correct my plan, or do I keep going? So it has this iterative approach, or it might say, this is a great question, but I'm sorry, based on the tools I have, no answer. Right? So we have this iterative approach, and once the agent determines that, OK, now I executed all the steps, then it will provide the information to LLM, and then LLM take, let's say, maybe lots of chunks of text, some breakdown, and then it will convert to more like human-readable format to present you in a friendly way, and you'll get your answer back. Here are the steps, and here is your monthly cost. So now let's see how we can actually build our first tool, which will be question and answer, utilizing knowledge base. So knowledge bases are nothing else as a vector store, so all the information stored in vectors, and there are currently 5 options at AWS to store it, with Amazon Aurora, Redis, MongoDB was added just a week ago, Pinecone, and OpenSearch Serverless. So now I'm in console. So the first thing that you will need to do is prepare your data. So the data should reside in a data lake in Amazon S3. So you might have multiple files. In this case, I downloaded documentation, some reference diagrams, and just saved them in S3. So you can have different type of data in S3 stored. Then you go to Amazon Bedrock and select knowledge base. So here I have already a few knowledge bases created, but I'm going to create a new one. So we select knowledge base, we provide the name, and then we provide a description. And it's very important to provide a good description, which will help our agent to understand when to use this particular knowledge base. So once you provide the description, then you select Amazon S3 bucket, select specific folder, can be in your account, can be in a different account. And that's really it. So now we have our source data. And now what we're going to do, we're going to select our embedding model to convert it to a vector store. So if you remember this diagram that Victor was showing, so this is exactly what's happening on the background. We are building this retrieval augmented generation. So now you can see the options, 5 options to select, OpenSearch Serverless, Aurora, Redis. I'm going to create a new one. You can select an existing data store, but just for a demo, I'll create a new OpenSearch Serverless, and now simply review the steps, and that's it. That's how easy it is to create a knowledge base. So it's going to take a couple minutes to synchronize it, and then once it's done, it shows available, and you can see here it converted 132 files and saved them in a vector store. So now I can actually test my knowledge base here right away in the console. So the first thing that I'll do, I will modify prompt, and I'll say, you're not just answering agent, you are solutions architect agent. And since I'm using Claude 3, which is a quite smart model, I'll say, well, don't only use the information from the knowledge base, but also answer to the best of your knowledge if you didn't find. So I modified this template. Now I save it, and now this template will be utilized. So now let's ask the same question. What it is ETL, with zero ETL with Amazon Aurora and Redshift. And because it was a recent announcement, by itself, Claude wouldn't know this information. So now I'm asking, and you can see it has these references. So it found 3 different chunks, and they're quite big. So then what it will do, the model will take these chunks and then understand how to provide them and summarize in the friendly answer. And we got our friendly answer that it's a real-time analytics together with Redshift. So basically, we went from researching several documents to simply answering, asking it and getting all the references and summarizing. Something that would have taken me hours, now I can just chat with this in seconds. But of course, this is how it's done in console. You will need to implement this in your own environment. So how we can do this? Well, actually very simple. It just requires 2 functions. First function we will define to get context. In the context, we provide our query, knowledge base ID, and the number, or maximum number of chunks that will be returned. And then we provide this context to our second function, which will be our tool. So this is our tool, answer query tool, and here we provide the chunks, and then we say, well, utilize Claude 3 Sonnet model, and then give this information in a friendly way and provide this answer to us. So that's how it is implemented inside your app. And now we can also test this to see if it's going to provide us answer. So let's run the same query. Tell me about 0ETL. And it's going to generate us an answer. And the answer looks a bit different. You can see it says, OK, it's a 0ETL is real-time analytics, and here are 6 key points. Well, the reason for this is because models are non-deterministic. Just like humans, you ask yourself a question again and again, you get slightly different answer, right? So let's get something a bit more actionable. Let's ask, well, tell me about e-commerce website and how to configure this. And now I run this question, and it actually found a reference diagram, one of the reference diagrams, out of hundreds and hundreds of them. And then it analyzed the diagram and got all the steps that required for configuration. So I went from searching through different diagrams now to very quickly getting an answers and implementing knowledge base. So now, OK, we got the diagram. But as solutions architect, we often ask to do trade-off analysis. So for example, this diagram is actually from 2017. And the customer will say, well, that's quite an old diagram. Maybe you launched some new services, how we can cost optimize it. Maybe I have a different requirements in terms of disaster recovery, right? How we can tweak it. So LLMs are becoming much smarter and smarter. So now with the multimodal capabilities, utilizing the vision function, we can actually tell LLM to analyze diagram and do this trade-off analysis for us. So this is what we're going to do next. And then once we narrow down our requirements, we can say, well, how about you now create infrastructure as code for us so we can spin and create our e-commerce website. So this is what we will do next. Claude 3 has different models. There is Opus, Sonnet, and Haiku. And depending on the model, they have trade-offs: speed, cost, and intelligence. So you probably see almost every week there is this new announcement. Oh my God, there is a new model being released, so now let's stop all the work and jump into a new model. Well, that's really not the case. What we encourage you is to evaluate different models. And I'll show you an example where utilizing, let's say, Haiku versus Opus, we can save 60 times on cost, right? There is a 60-time difference. And by providing a little bit tweaking the prompt, using prompt engineering techniques, we can guide our model and get the same answers. So try to evaluate the model, try to understand when to use particular model. So how you can do this? Well, there are different ways. The very simple and easy way is utilizing Playground in Bedrock. So here, let's say I got my diagram with e-commerce website. Now I want to analyze and say, provide me cost optimization tips. So I'm going to select Sonnet model, which is the middle model, and then I will select the fastest and smallest model, Haiku. So this is a diagram. You can see there are some numbers from 1 to 9, so some of the components marked. So we'll say, well, explain this to us. So act as solutions architect, explain what you see on this diagram, and then provide us cost optimization tips, and generate Terraform code so we could then launch this particular solution. So now you can see I'm executing it against Sonnet and Haiku. And as you can see on your right, left, on this side, there is a Sonnet answer, and it generated descriptions of 9 steps and provided 6 cost optimization tips and created Terraform code. And you can see on this side, there is a Haiku, and it's also created, it identified all the 9 components, created 5 optimization tips, and actually provided a bit longer output. And here are the metrics that you can compare. Haiku was a little bit faster and provided a little bit longer response. So with this, if you don't need to use Sonnet, use Haiku. You will save 12 times on the cost. OK, so this is great, how we can actually implement this in production. We're obviously not going to copy-paste from chat the Terraform code, right? We want to have a version control. We want to implement some kind of test before we launch it, and also understand how much it's going to cost. So what we will do now, we will create a tool that will generate for us a Terraform code and save it in S3 bucket. So here is a very simple code. As you can see, the majority of this code is actually our prompt. We are saying, act as a DevOps engineer. So we are assigning a role. Then we say, well, don't provide us any kind of explanations. Only create code. Don't apologize. Code likes to apologize. So we encourage the model and guiding it to provide to the answer that we really want to have. And then we will save this into S3 bucket. So now I'm ready also to execute the second tool. And let's see the result. So here I'm just providing, since we've been utilizing Magento, I'm just saying utilize the Magento open source for our e-commerce website. And now as I execute, it generated Terraform code now and in S3 bucket. And we can validate that the code is there. Of course, before we launch it, we want to understand how much it costs, right? We don't want to start spinning the infrastructure and transforming Terraform into costly bills. Well, I don't know about you, but whenever I try to go through AWS pricing, I often felt that I needed to have a PhD in finance to really understand how much this particular solution will cost me. So, Victor.
Yes, that's true, because sometimes when you want to figure out what, like the cost model, I also not graduated in PhD finance, but I want to show you how we can very quickly to estimate the code, Terraform code, what's Victoria generated. So it will be our third tool in our complex agent, and we will use external tool. It will be infra cost. So it means like we will call external tool to do for us this estimation and return. From architecture perspective, how it will be looks like. So we already have our code, so it's stored in a S3 bucket. We run Lambda function. Inside in these Lambda functions, we will integrate infra cost. I will show just like in a few seconds in demo how we will be able to do it. Evaluate the result, send this context to our LLM, and ask to analyze. But output from infra cost, it will be amount of money, estimations amount of money, how much it's cost of this proof of concept. So for example, in my case, $600. So let's see in a real example how it works. So again, I'm going to use open source tool. It's called InfraCost. You can install it in your Windows, Linux. In my case, I'm going to use Docker image, because inside of the Docker, I can just like copy this binary file. So the latest version on InfraCost is 0.35, something like that. It was latest version 2 weeks ago when we made the recording. For sure, if you want to use paid version, you can go to AWS Marketplace and find InfraCost there. So we here in our S3 bucket, we have our Terraform code, and our currently goal, just like download this Terraform code, estimate, and return a result, and ask our LLM to provide some, can you please recommend for me some cost estimations or where I can save some money. So here we go, we back to our Cloud9 console, and in the same way, I'm going to run my new test tool. So here we go again. The top all of these tools, it's very important to understand prompt engineering. Again, I said for my model, please make double calculations. Be mathematically accurate. Because if you don't provide the correct prompt, most probably you will get not the right response. So be very careful. So here you go. In this code, I just download my Terraform code, what's Victoria generated from S3 bucket, not so complex. I will be very honest with you. I also generate this code using Amazon Q. So yeah, here we go. The next step, I just run infra cost. So in my case, it's just CLI, and I provided this parameter what I needed, where I place my Terraform code, and that's it. Here we go. It's my final step. I want to ask Sonnet, Anthropic Cloud 3 Sonnet version, can you please send me where I can save some money or distribute the cost between compute layer, data layer, and so on. So here we go. When we run infracost and output, we will see these images. I mean, like this output. At the end, for sure, it will be the cost amount of this whole infrastructure. And also, we see the spread between different types of the services, like load balancer, for example, or net gateway, or something else. And at the end, so from LLMs, it's returned and said for me, hey, you are going to spend in this solution for your virtual machine, for your EC2, some amount of money, something else for other services, some another amount, and so on and so on. Estimations, $270. Sounds good. So we already built 3 different tools: knowledge, generate a code, and estimate. And it sounds like we're ready to build it in one solution, in one agent. So as you can see, agents, it's built between different tools, but we also need to provide this connectivity. So when we want to create agent in Bedrock, we create our action group, it's our Lambda, it's our actions. We provide data source, it's the heart of our agents, our knowledge base, what Victoria did in S3. And also we can interact with agent. So in our case, what it will looks like: 3 different tools: Q&A, knowledge base, generate a code, and estimate. And everything is placed in Bedrock. It means like you don't need to spend a lot of time to build your own custom agent. So you just combine all of the 3 components in one place. But it's also very important when you create these tools, these actions, you need to provide like how I, as LLM, understand that I need to call these actions sometimes in other actions. We do it through the API schema. In API schema, we describe prompt understanding for our LLM when I have to call some of the functions, and based on this API schema, I make the connections to my Lambda functions. Let's see in actions how it looks like. So we are going to build our agent. So here we go. I am in my, again, Cloud Now console. And let's look at our final Python code where I put everything in one place. So you see here we have answer query, generate a code, estimate the code, like everything what we did previously. Again, one more time, prompt is very important. You see in every tool we provided this prompt ending. How I'm going to pack it in one place? Lambda. But for Lambda, it will be container. So as a baseline, I use infracost as image from infracost distributions. And inside in this container, I just copy this binary file from infracost container to my Python container, which I'm going to run for Lambda functions. Also, as you can see, I install additional requirements, which is very important for my tools. And copying my code, that's it. Not so big deal, so it's pretty easy how we can do it. And what else? API schema, already mentioned. This is how it looks like. We need to generate API schema, which help us to understand when to call different tools. This is how it looks like. And what will be the handler of my Lambda functions? This is my logic to call different tools, like, for example, if based on the context, what's the customer or user ask my agents, I understood that I have to call answer query, and I do it. So here goes my Lambda functions. As already mentioned, I distributed as Docker image, so you can deploy new versions, upload new versions, like the same way how you work with Lambda functions. What will be very important to make the configuration when you work with generative AI agents? First of all, make sure that you adjust timeout. By default, 3 seconds. For generative AI agents, it's not enough. In my case, I just put it 3 minutes and 2 GB of memory. So what else? Security. List privileges. I just provide the right permissions for my Lambda functions. My Lambda functions is going to call Bedrock models. So I provide this access and also interact with my S3 bucket. Get the data, like my Terraform code, and upload my data to S3 bucket. Also, what's important, Bedrock is going to call my Lambda functions. So for that reason, I also define that Bedrock has possibility and has permission to call my Lambda functions. Also, in environment variable, as I use open source tool InfraCost, I need to provide API key how to just for this this tool. So you remember API schema is very important. Victoria later will show how you can generate it. But in API schema, in short version, what we have? We have descriptions of all of the tools, all of the handlers, what we have inside in my Lambda functions, and custom logic, what I have to call and maybe adjust based on this input parameter from my users. So sounds like we prepare actions group. Yeah, so it's time to build our agent. So I'm currently based in Bedrock, and I already created my own agent. As you can see, I call it my last name. So agent AWS Solution Architect. And what we see here, so first of all, I want to pay attention for you that you have versions of your agents. So maybe you need to create different versions just to test new capabilities. But the main configuration you will find in this area. So first of all, the role, least privileges. Security, very important. Don't provide root access, admin access for your agent. Also, you have capability to select what the model will use inside in your agent. In my case, it will be Anthropic Claude 3. And instructions. What the role plays this agent. So solution architect, certified, all of this stuff, prompt engineering is very important. To define how my agent have to do different stuff based on the input parameters, input context. Also, we have knowledge base. Already you saw how we can do it. We uploaded more than 100 documentations, reference diagram, and actions groups. It is where we make this connectivity between API schema and Lambda functions. So I just select existing Lambda functions, what we uploaded and store as a container, and describe where I store my JSON file for my API schema, again on the same S3 bucket. Here we go. So it's my API schema file. And for sure, I want to provide capability to interact with my agent. So when you're ready, like when you build these agents, you have to prepare the agent, like to run preparations, prepare these agents, and be ready to start to play with this agent. But before we jump in and test the agents, I want to pay attention for you that you have to be very careful. I mean, like when you create API schema, actions, make traceability for your agent. Why it's so important? Because sometimes you don't understand why agent call another tool. So in Bedrock, we provided these capabilities, tracing. So you see what the context, what the decisions from the agent was during the executions. Like, I need to call these tools or another one. I'm going to take this data from knowledge base and so on. So let's test my agent. What I want to ask my agent in these situations, please generate for me Terraform code for e-commerce application, but I'm a little bit more specific. I want to ask my agent to generate Terraform code for the applications which have to proceed with 200 requests, and inside in these commerce applications, I want to store 2,000 products. So if we go from the right side, it's my yes, I believe right side, doesn't matter. You see the traceability. We see the context, what's going on inside in the agent. And here I understood, like, the agent is understood like, what the context is, what's the goal, what's the purpose of this request. And the agent is going to call my two different tools, generate code, Terraform code, and estimate this code. So this is exactly what the agent is going to do. It was on pre-pro setting, like before to run all of these executions. First step, like you saw, this is my prompt. I would say, I don't know, maybe I said it 5 times or 7 times during my presentations. Prompt engineering is very important. Again, we saw the same prompt, what we provided for my agent. And also we saw it's going to call this agent, these tools inside in my agent. Done. Terraform code is ready, stored on a S3 bucket. We see where we store. I can go and download this Terraform code. Also, we see like already have some additional step. Here we go. You see it's already generated output. But I want to show you very quickly what the traceability, what the trace inside in my agents we have, and how I can understand what's going on and why agent called some part of the tools. So you see it's called estimate tool based on my request, understood, and the result, it will be in the last step in the trace number 3. The same output, what we see from other side, what is returned to my chat communication window. So it's said like I generated Terraform code. You can find it in this S3 bucket. Also, I estimate this Terraform code. It sounds like your solution, your prototype, will be cost around $300. This is how easy and quickly we can do prototype and estimation.
Now imagine if I had a tool like this, how much time I could have saved, right? Like from just asking a question to getting all the information immediately, getting my proof of concepts that I can launch, and also getting the cost right away. And I can follow up, right? I can ask other questions. Now, help me to build for my e-commerce website this real-time analytics with Redshift. Give me all the steps, and I just can keep going and going. And really, what we want to do in this session, not so much to talk about how to build solutions architect agent, but just to show you the possibilities so you can think about what are those kind of tasks that at your work you can automate, right? And kind of like spark those ideas so you can focus more on the strategic work rather than doing this time-consuming, repetitive work. So we want to finish with a few main takeaways. So first of all, AI is here to help us, to empower us, not to threaten us or replace us, right? And in order for us to really utilize the power of AI, we want you to remember few things from the session. Not so much about the steps that we were showing in the console. I can tell you, we had to re-record the demos at least 5 times in a couple weeks because there are constantly launches being done, so some of the things will change. But the core concept, so the first thing is prompt engineering. So you've seen us trying to guide the model, saying, well, you are a solutions architect, assigning the role, or you're a DevOps engineer. Then tell the model, well, think step by step carefully. So we try to play with different playgrounds, try to take maybe some courses on prompt engineering, because if you know how to speak with AI, it will be just much better for your communication, right? Second is evaluate different models. So in our case, you saw us using Haiku somewhere. We try to use Sonnet. Let's say maybe to generate code, you might use some generic model because it's better for code, right? Maybe for vision, to understand diagrams, you would use a different model. So try to evaluate for each specific task which model will help you. And then the last is break down agents into small agents. So for example, we just showed you how to create an agent that will create a Terraform code. But let's say maybe you're interested in CloudFormation. Well, for CloudFormation, it would be better not to use this generic infrastructure as code, but rather create a separate agent that might use, let's say, Amazon Titan model on the behind, and also optimize specifically the prompt, create a different pre-process and after-process. And so the better you define your task, the more accurate answers you will get, right? So go from ambiguous agents to small, specific agents. Now, to help you get started, I think the best way to learn is by building. We prepared a few resources. You can take a picture of this. So the first is a workshop. So the workshop provides step-by-step how to build AI agents with some of the examples, some of the things that we couldn't just cover in today's sessions about fine-tuning, how to build security. So you can also try it in this workshop. Second is a GitHub repo. That's where you can find a lot of code samples that you can utilize using different examples. And lastly, You saw Victor providing the how to generate open API schema for Bedrock agent. Well, I prefer to automate things and let AI write the code for me. So we have this Party Rock application where you can just describe what kind of tools you have, and then the application will generate for you open API schema, because we love to automate things using AI. So I hope this session inspired you to think about your examples and enjoy the last summit at Berlin. Thank you so much.